Hello everyone and welcome. In this episode we will look at message from the energy meter and we will create the code for the Arduino and also for the magic mirror in Python. If you haven't watched the first video where I build the hardware, I would suggest you to go back and watch that first and then come back to this one. But first of all, I will just show you where to find information about the HAN port interface, which actually based on the same as P1. So you can find this document. I will put a link down below for you. And we just have a quick look in this document. We can see details on the interface itself and the pins and so on. You can see the picture with the optocouplers and power supply. And then there are a lot more details, but going further down. You will also get details on the protocol. You can see it's 150,200 baud. And you can also see that the messages are terminated with a new line feed characters, and the data lines as well. And what we're really interesting is a bit down below, where we find the table of the different measurements and the different values. So for example, this code is important, and then you can find out what's actually represent in the message. So if we have a quick look at the example here, you can see that this is similar to what we got back from the energy meter. And this is how we will interpret it in the Arduino. For those of you who are from the Nordic countries, there's also a Swedish page where you can get a bit more descriptive and more a bit more explanations about the HAN port, if you can read it. Let's continue with the code for the Arduino. First of all, I want to add some variables that I will use to store the meeting values as I retrieve them from the energy meter. Some of them will be in float and some will be integers. Next, I have prepared a part here for interpreting the meter values. So if we have a look here, we can see that I have added the codes. For example, this code means that it's the meter value of outgoing energy. Then you have incoming and so on. And if we have a look at the messages that I received, I saved one here from the energy meter. You can see that we have the similar codes here. So what I will be doing is actually to scan the messages received and looking for these different codes. And if I find one, I know what value it is. And then I will store it into my variables here. So I have a list here. I have also added a clear text, mostly for printing and debugging and so on, but I have a clear text value as well. And then you have a couple of static variables to identify the different codes and text in the above list here. So if we scroll down to the setup part, nothing has changed here. I'm initializing the two serial ports, one for the console and one for the HAN port interface. And in the main, I will be adding a few things. First of all, I will be reading the message. So if I have anything available in the buffer, I will first read a message, and then I added another function to decode the message. And I will show you that one. The next part here is actually just for debugging. Since I'm not connected to the NUmeter right now, I have added two different types of messages that I will generate every 3 seconds, and then I will decode those messages. So this is just for testing and for making sure that my message decoding is working as it should. So I will be using this now and later on, of course connected to the energy meter. So if we have a look at the functions here, the first one is just to read a message, and it's almost the same as before. I'm reading the buffer until I find a carriage return. And then let's have a look at the decoding of the message. So the first thing I will do is that I will scan through my array of message codes that I'm looking for. I will start with the first one. I will check the size, the number of characters of the message code. And then I will compare character by character, counting up this value here. And in the end, I will compare how many matching characters I found, and if it's the same as the size of the code that I'm looking for, then I know that I have found the message. And I will set a flag for found message. And if I don't find it, I will continue to the next message in my array. So if we have a look at the array, I will check code by code. First this one, going to the next one, and so on. And I will continue to do that as long as I have any characters left, basically. And when I found a value, then I will first extract the value string. And if we look at the message, we can see that we have the value string here just before the star character. And that's actually what I'm looking for here. So I will extract the substring. I will also print it on the console to show what I have found. And then I will use my static variables here to compare with the message number that I found, because I want to set different values depending on what I have found. So in this case, I found the value for the energy meter, and then I'm setting my value for that. And there could be a bit different settings, and that's why I have split it up in an if-else loop here. As you can see, some of them are float and some of them are integers. And I have just added the ones that I want to have and I'm looking for. You could probably do this in a more efficient way, but since it's not so many values, I thought this would be the simplest way to do it. So now we have retrieved the value of the messages, and we know what message we have found, and we put them into my my variables here. So if we go back down to the main, we can actually test this now since we have added this test loop here. So let me download it to the Arduino. let's turn on debugger. And we can see that I'm actually retrieving the two test values here. Effect out, meter active out, and those are the two test values that I put in. So the message decoding seems to work fine. Let's continue with the Wi-Fi connection. So we have the values, and we have retrieved them from the energy meter, and now we want to upload them to the Magic Mirror. For this, I use pretty much the same code throughout my Arduino devices, and I also use the Arduino Nano 33 IoT, and that's one of the reasons is because it has a built-in Wi-Fi. So it's quite simple to get it up and running. The first thing I want to do is to initiate the Wi-Fi. So I will make sure that I have the libraries loaded. In this case, it's the Wi-Fi 9 library for Arduino. I set some static variables for upload delay, and I also set the port that I will be using for my Magic Mirror. In this case, it's 8082, and that's for my test pages, and then I have an 8081 for my normal Magic Mirror. In this case, I've added Wi-Fi password and SSID in clear text. There is actually functionality in your Arduino Nano in the IoT to encrypt this. I haven't implemented it here, but it's there. So if you want to be on the safe side, you can just add that. And then we have the IP address of my Magic Mirror. And then we initiate the object and call it client here. And I will also monitor the Wi-Fi status in this variable. Then I have a function for uploading the results. I will come back to that one. So let's comment it out, and then we will go back to this function later on. This. And then we will go down to the setup. And here we will initialize the Wi-Fi. So we will start the Wi-Fi. We will connect to the access point with the password provided. And we will also print a message if it's successful or not. Then we will jump into the main. And here I also have some Wi-Fi functionality. Basically, it's checking if I'm connected or not. So if I would lose the connection to the Wi-Fi for some reason, I will wait 20 seconds and then I will retry the connection in. And this is quite useful since you don't want your devices to you don't want to reboot your devices too often. So this is useful. If you have any problems with your Wi-Fi, it will automatically reconnect. Then if we continue down in the main function, I have the last part here. And here I use a timer, and I use the variable, the static variable for the upload delay time. And in this case, we can check what the value is. It's set to 20,000, that means 20 seconds. So I will upload data to my Magic Mirror every 20 seconds from the energy meter. You can do it more often if you want, but from experience, it takes some time to retrieve the data from the energy meter and so on. So 20 seconds is quite good. And here we will call the function to actually upload the results. So let's have a look at that. This is also following the same structure as I have in all my Arduino devices. First of all, we do some housekeeping here and making sure that we have a known status of the access, so we don't have any ongoing messages or anything. We stop them and we flush the buffers, so we're ready to do it from scratch. The first thing here is to connect to the Magic Mirror on the port 8082 and making sure that we are connected. There I can actually see that I missed something. Should have the port here as well, like that. And then you can see that there are also some reconnection logic here to basically jump out of the function if I have any connection problems, and then it will automatically retry. So I'm making sure I'm connected to my Magic Mirror and before I start uploading. Here I use a library for JSON, and it's Arduino JSON. And this is for constructing the JSON message that I will post to my Magic Mirror with the data. I found this to be the best way actually for me to do this. So I create a message, a JSON document, maximum size 1000 characters here. That's well enough for this. And then I add the JSON items, JSON variables to my JSON document. And most of them I think is pretty clear. I want to have a date time stamp on it because I'm getting that from the energy meter, and I want to send that to the Magic Mirror so I can use that if needed. And I also add a value down here that I call runtime, and this is basically for monitoring the Arduino device so I can see how long it's been running for, so it's not rebooting or anything, that I can keep track of that. And then you can see I have one that is underlined in red here. That is because I haven't added my temperature meter yet, which I will show later on. So let's comment that out for now. And then we have some HTTP message settings, parameters that we need to send. Content set to JSON and the content length and so on, the host name. And here you can see the essential part. We're actually printing the JSON document that we constructed to the client. And this is where the message is posted to my Magic Mirror. And up here you can see the function that we're doing. We're doing a post. And then we also have the page that we are posting to. And we will see this in the Python code later on. So we're posting the JSON document to the Magic Mirror and the page energy meter. So what then will happen is that we will receive a message back from the Magic Mirror, the result. And here I'm making it quite simple for me. I'm just checking if I did receive any result, and if the size of that result is more than 0 bytes, then I consider the data to be uploaded. Here you could of course evolve it and check the result codes and so on, and do different actions depending on what you receive back. In my case, I just made it simple for me, and either I succeeded in upload or I didn't. And then I also have a functionality to count the number of failures I have. And if it's more than 10, I will stop the client and disconnect the Wi-Fi, and then it will automatically be connected again in the main loop. So that's just a safety feature to make sure that for continuous problem, I will just reconnect the Wi-Fi. And then at the end of the function, I release the socket so it can be used for other things if needed. And now the message is posted to the Magic Mirror. Next, we're going to add a small display, and we're going to add a temperature sensor as well. So let's complete those things in the Arduino before we download it and do some final testing, and also, of course, add the code for receiving this data into the Magic Mirror. So first of all, I'm using a small OLED display that's compatible with the controller SSD 1306, quite a common one. And it's using I2C for the communication. And this case, I'm using the library from Adafruit, which I found works fine. So let's initiate that, and we also initiate the temperature sensor. In this case, I'm using the Dallas 18B20, which is a one-wire digital temperature sensor, and I'm using it in almost all my projects. It also has different. You can have it waterproof, and you can have metal capsule for it, or you can have a plastic one, or so there are different variants of this one. So I have added the Dallas temperature library here as well. And I will also need the one-wire libraries for communicating with the temperature sensor. As you can see, it's initiated here. First the one wire, and then that's used for the Dallas temperature library. And then we will also add the variable for the temperature. So let's have a look at those parts. We'll scroll down to the setup first. Here we start by initiating the temperature sensor, starter sensor. I have a small delay here to give the display time to settle before I'm initializing the display. And then we're clearing it, setting text styles and colors, and placing the cursor at the first character. And in this case, I'm actually printing initialize Wi-Fi. So if anything goes wrong, I have a chance to see it on the display as well. The last command here is actually what's sending the text to the display. So that will output the text to display. So initializing clear, and then we move down to the main. Okay. Here again, I'm using this way of using timers to decide how often I want to do different things. I guess you're familiar with this principle in the Arduino, since the main is looping all the time. You don't want to introduce any delay in the main. You want it to be as short and quick as possible. So that's why I'm using timers here to make it possible to have a very quick flow of the main and just doing stuff when I need to do it. So in this case here, I will update the display every 1 second, 1000 milliseconds. And here we can see that we have some debug code left. We will remove that. And the first thing I will do is that I will check the temperature. I will request the temperature from the temperature sensor, and I will also get the sensor value by index. Since I only have one sensor on the one-wire communication, it will always receive the index 0. So here it's simple, but if you have more than one sensor on the same one-wire communication, then you need to do some other stuff to keep track of which sensor is which. They do have a unique ID as well that you need to identify. But in this case, I only have one, so it's simple enough. And then I will print the temperature on the console. And then we will continue. As you might see here, we are missing the actual displaying any values, but I want to show you the function first. So if we scroll up a bit here, I prepared a very simple output function for the display. So in this case, you could say that I have two pages, page 0 and page 1, and I'm changing between them every 1 second, since that's how often I'm updating the display. And here I first need to clear the display completely. I set up the text size, colors, cursor, and then I print my values. So the first page will have the value of the energy meter in kilowatt hours, and it will have the current consumption in kilowatts. And I used Arduino string functionality here to print it in a simple way. The second page will just display the temperature. So let's add this to the main as well. I wanted to add it here after I have retrieved the temperature values. I will just update the display as well. You might remember that I commented out one value here. That's here. We want also to upload the temperature to the Medic Mirror, of course, so we can show that if we want. So let's try and download that to the Arduino. That worked fine. But I will have some problems because I didn't put in the correct Wi-Fi password for you, and I also haven't created a page on my Raspberry for the Medic Mirror yet. So that will be the next step, to do some Python coding.